Welcome back guys, Amar here from Magic Coding, and in this video we are continuing with our color helix project. Now in this video we're gonna add up, I can say it's kind of an algorithm for spawning walls, so let's just jump right into it. From where we're gonna spawn our walls will be pretty simple. It's from our game controller, so just go ahead and open that up. And we are going to create our void function that will be called spawn walls, just like this. For the spawn walls to work, we'll have to add one more integer, which will be our private integer walls spawn number. This will be how many walls we will spawn. By default, I'm going to put 11 for now. I mean, even though for this particular video it's not necessary to have this, we will need that later on. Now we're gonna create a for loop for our spawn walls, and we're gonna add our for int I equals to 0 if I is less than our walls number spawn number. Then we're gonna do the block of code which we'll add. First we're gonna have our game object that we're gonna call wall. Then we're gonna say that our wall equals to instantiate, not instance, but instantiate, here we go, instantiate, and we're going to instantiate our resources dot load, and we're going to search for the wall, and we're going to transform it to we're going to transform it as transom.position, add transom.position, and quaternion.identity for the rotation, so identity for the rotation. And I forgot to add here as a game object, so as game object, that's how we want to spawn our wall. Next up will be our wall.transform.setParent, and we're gonna set parent to our game object, so not fame but game object dot defined, and we're searching for the helix.transform. And why we're doing that? Well, if I spawn wall here, we did that in our previous video, if we spawn it just in hierarchy, it will not move left or right when we move the helix. But if you put it to be inside of the helix itself, it will move on the rotation Z, meaning that it will move the walls with them. So that is why we are setting parents for our wall to be to helix. Then we're gonna have our wall dot transform dot local position, so local position equals to new vector 3, which will be 0, 0, and Z for the Z. Now to add Z, we'll go ahead and add it like right here. We can make it an integer or a public or a float, depending on what you want. I'm gonna keep it as our private float Z. Then after we added our Z, we're gonna add our float random rotation. We do not want to spawn our walls at the same position, then the game will be easy. We're gonna randomize that by having random.range, and we're gonna random from 0 to 360, because that is how we can spin. Then we're gonna set our wall.transform.local rotation, so make sure you keep local in, equals to quaternion.identity, then new vector 3, and we are setting 0, 0 for the Z and the Y, and the random rotation from the Z axis. For the Z axis. Come on. And then last but not least, the differences between our walls will be 7. So we're going to say Z plus equals to 7. Every time we do this block of code, we're going to increase the wall of 7. In the awake, or we can say in the start function, we can say here, our Z will be 7 to start things off. It will not be 0. Now we can go ahead and add, I'm just going to change update for now to start, and we're going to have our spawn walls to see if it's working. So as you can see, we are doing a loop where we create a game object, which is our wall. we are referencing our wall to the wall that we have here that we made in our prefab. Where is it? Come on, Unity, don't do me like that. I was kind of in the mood. And you see, we're instantiating this wall here to the helix. Then we are setting it to the helix transform parent. Then we are setting its local position to be at the Z, which is by default 7. Later on, it's going to be increased. And we are putting a random rotation. So let's start our game to see if it's working or not. And as you can see, it worked except the rotation. Now the only problem we have with rotation is in our wall. So if you remember, we had to change the transform.local position to 0. Now we have to do the same thing for the local rotation. So like this. Vector 3.0, will it work? No, we have to say a new, it's quaternion.illular then vector 3.0, just like this. So copy this and paste it here also. And now our rotation should work because as I said, we're having the same problem as we did for the sorry about that, for the position. As you can see, it is working. You see, it's randomized where we should go, where we should not go, and so on. And right now, we're currently not doing anything. Let's just go ahead and do that for the video. Or actually, no, I'm gonna leave that for another one. I do not want to keep things long. I just want to keep them short, quick, and really to the point where you can guys understand. So yeah, that will be it for this video. Hope you to see in the next one, and goodbye.